Hi everybody. Today we're going to talk about the standard normal probability distribution. Um, I'm going to be talking about the concepts quite a bit here. Towards the end of the video, we'll actually be finding like numeric answers to problems. Typically, I find this to be an area that students get very confused on because we're going to talk about z-scores and what do those mean. Usually students don't worry about what they mean, they just want number answers, and because of that, this can be a very confusing section. It does not need to be. If you understand what these questions are asking, it's not nearly as disorienting when you're trying to figure out what a problem is asking you. So let's just start from scratch. We have something called a standard normal probability distribution. Now, what does that mean? Well, imagine I wanted to take measure the height of every person in the state of Michigan. Now, let's say we could do that, and we did it, and we had all the data. If I put all the heights right here on this x-axis, like, if I start from 0 feet and I go up to whatever, like 10 feet. So most people would be somewhere in the middle, right? Like in the 5 to 6 foot range. And then we'd have like 7 and 8 foot people. And we'd have like 2 and 3 foot people. Let's say we're only talking about like adults. Then you have a spread. Like people are all kinds of heights from not low numbers for height and high numbers for height. But most of them are going to be in the middle. That's kind of inherently what a normal distribution looks like. They're more clustered by the mean or the average. But there are people that exist. There's data that goes out to these edges. Just the further out you go, the less of them you'll find. So what we're going to do is we're going to try to figure out, well, how can I start to get specific if I know that kind of like people's heights and people's IQ and like squirrels, mass, like whatever, if things in nature tend to follow or obey a normal probability distribution, what if I knew a little bit of specific information about this, like where the average was, and I knew like the standard deviation, how spread out the data is? Could I start to like say, well, what percentage of people are below this, like below 6 feet or above 4 feet or whatever, or between 4 feet and 6 feet? See, that's how we take this basic idea and start getting specific. Let's say it's 6 feet is right here. How many people are above 6 feet? What percentage? That would be these people. If I wanted to know how many people were above 4 feet, 4 feet would be further back, like 0 feet, remember? So the percentage of people above 4 feet would be all of this. See that? Like this, all this region right here is 100%. So the people above 6 feet would be, I don't know, what do you think that looks like? 25%, right? Out of the whole thing, maybe 25% is covered. If it's the people greater than 4 feet, then maybe 75% of the people are covered. See, this is all people, the area under the curve. And we're going to be talking about, well, what if I want just this part, right? This part. What if I want just like the part between here and here, just this region? What percent of the total is that? That is what we are doing. So now let's start getting specific. The things we need to know is what's the mean? The mean on this picture, the very peak of that hill, that will be the mean of this data. Now, we already kind of learned in a previous section, a standard deviation is how spread out the data is. And in a normal distribution, probability distribution, let's go 1 standard deviation. So this is 1 standard deviation. 2 standard deviations. Here, let me write that bigger. 2 standard deviations. So this is 2 standard deviations. And I'm trying to space these out equally. 1, 2, 3 standard deviations. So that distance from the mean to there would be 3 standard deviations. And I could also go backwards. So if I go back one, this would be -1 standard deviation, -2 standard deviations, -3 standard deviations. So see, what we do is we draw the picture. The mean is kind of where we measure from. The mean is kind of like the 0. And then we're counting by standard deviations. 1 of them, 2 of them, 3 of them. 1 back, 2 back, 3 back. Okay. Now previously we learned that this region right here, if you go back, you'll see like this was actually like a test question. What percentage of all the data is in there? And it was, if we round to the whole number, 68%. And then if we said within 2 standard deviations, that would be all of this and including the middle chunk. So how much of, what percent of the data is in the red there? 95%. Remember, that's what we called statistically significant if it was within 2 standard deviations. That's most of the data. And if we go within 3, that would be everything except these very end tails, right? That's almost all the data, and that's 99 point, what is it, 99.7, 99.8? Almost 100% is the point. That's all, like, most of the data. Now, a z-score, which we have to understand, that's all we're going to be talking about is z-scores for this whole unit. A z-score is a standard, how can I put it? A number of standard deviations. A number of these. What does that mean, a number of those? Well, I made my picture all messy. Let me clear the deck. Okay. So I have my normal curve. I got to find the mean is right in the middle. And then I'm going to go 1, 2, 3, 1 back, 2 back, 3 back. See, I'm scaling it just like I scale an axis normally, except instead of starting from this axis, I'm starting from the mean. You know, for now, let's just get rid of this, right? So this is like 0, and then that's forward and that's back. So let me throw out some z-scores for you. If I said a z-score of 1.5, that would be right here. 1.5 standard deviations. That's, see, a z-score is how far on this axis. If this is, the mu is like 0, this is 1.5 standard deviations from the mean. We don't say that. That's the part in your head you got to understand. Well, it helps if you understand that. 1.5 means 1.5 standard deviations from the mean, and it was positive, so it's over there on the positive end. What if I said z is -2.3? Well, that's 2.3 standard deviations behind the mean. So if this is the mean, I got to go back 1, 2, and 0.3 might be around here, minus 2.3. What would a z-score of 0 be? Well, that would be right there on the mean. It's no standard deviations from the mean. What's a z-score of 0.68 look like? Well, that would be between 0 and 1. So that might be right about here, let's say, 0.68. So the first thing is to understand when you see a number for the z-score, how do you find it in the picture? Now, you don't have to draw the picture, but especially if you got one in front of you, like if you're looking at a problem, I think it helps to visualize this. Okay, let's take this one step further. Now that I know, like when I see this z-score, I can find it on my axis. How do I answer questions? So let's do our first question. Probability z-score less than 1.5. Oh. Alright, I'm going to do this problem and then I got backtrack. What is the probability that the z-score is less than 1.5? Well, the first thing I got, that's 1.5. First thing I got to do is find 1.5. I go, okay, the mu is the 0, so that's 1, 2 is too far, 1.5. So this is a z-score of 1.5. Less than, if I draw that straight up to where the curve is, less than would be all of this area right here. So I want to know what percentage of that hole under the curve is behind the 1.5. How do we get that number? Well, it's nothing mysterious. There's two ways to do it. Way one is with a table. That's this video lesson. We're going to just use the table. Way two is using the calculator, and that will be our next lesson. And I'll try to show you how to type these in on your calculator. You know, the problem is people have different kinds of calculators. So I'm going to show you like with the TI-84s, I think it is, and I'll try to give you some resources, like if you have a different model, like how to type it in. It's a pretty common thing to do. So whatever kind of calculator you have, it will be very easy, I think, to find other videos on how to put it into your particular calculator. This is a very important part of statistics, and it should be very easy to find that information if you do a search for it. But first, let's start with the tables. We don't even need the calculator. So, and that's why we're going to cover it, because what if I'm having trouble with my calculator? All right, so what we're going to need is your book. And I'm going to try to find probably an online version of this, but let's find the page first. In your book, here, let me hold on to this. On page 76, there's a fold out here. And it says negative z-scores, positive z-scores. Okay? And notice how it's got the pictures up here. And notice how it says that all this data in here, I don't know, can you see? All the data in here, it says at the top, cumulative area from the left. So whatever the z-score is, it's going to be on the left. Kind of like what we're doing here, it's on the left. So how do you use this table? Well, this is a positive z-score. This is, see, 1.5 is a positive. So I got to go to the positive z-scores. And this is the first decimal place in this column. So I'm going to go 1. I find 1.0. Oh, it's got 1.5. My bad. So 1.5, I got to follow this. It'd be that first number, 1.500. So this is like the ones digit, the tenths digit, and then if you have hundreds and thousands, it would be which column here. We'll do one like that next. But this is 1.5 exactly. This is 0.00. So that's 0.9332. 0.9332. I got that off the table. Now that's really awkward for me to hold that because it's 2 pages. I happen to have one page that's 2-sided. It's a lot easier for me to do on this video. And I'll try to get one of these to you. I can provide it in Brightspace. So this is the negative side, positive side, 1.5, 0.9332. There it is. So notice I just looked it up. But what does it mean? It means 93.3% of the people would be behind that particular mark, like that many standard deviations. So maybe that's like your 6-foot mark. 93% of the people are below that 6 feet or whatever. Let's do another one. Let me use a different color. What is the probability that the z-score is less than, let's go minus 2.341. Let's add some digits here. So first, let's find it on the table. Minus 2.341 would be about here. So I'm going to go up to there. And what I'm interested in is how many are less than that. This should be a very low number, right? If this is 100%, everybody under the whole curve, that should be very small. So I'm going to go to my table. We'll see if I can get it here. And I want minus 2.3. And now it says 4.1. So I'm going to... So this would be minus 2.34. So this is the digit we're looking at. Minus 2.3 is right here. And then this is the next digit, the 0.4. So I have to go down. And I want 2.34 right there at that mark, which is backwards. Let's see. I got to look at it right ways. 2.34 is 0.00964. Can I get that whole thing in the shot? 2.3, the first couple digits. 0.04 looks straight up above 0.04. 2.34 is 0.00964. 0.00964. So that means approximately 1% of the people would be under whatever that height is. That didn't feel like it went too smoothly. Let's do one more, and then I got to back up and give you kind of another piece of information that makes this all true. But let's do one more example. Actually, we got to do a few more here. I better tell you this up now. All right, in order for it to be, this kind of gets into the next lesson. So right now you don't really care, but for it to be a standard normal, the mu has to be 0. We've been treating it like 0. The mean has to be 0. And the standard deviation has to be 1. If that is true, then this is a standard normal. After a couple lessons from now, we're going to start messing with those values. So if we wanted like the mean to be 6 foot or whatever, we could put 6 here. But for right now, we have to have that the mean is 0 and the standard deviation is 1. And that's what we've been doing. You just got to pay attention to that later, a couple lessons from now. So if I wanted to know the probability that the z was less than, we're just doing less thans for now, 0.047. 0.047. Sorry. 0.470. Let's not go quite that far back. 0.470. How would I do that? Well, on my column here, I'm going to look for 0.4. It's way up at the top, 0.4. And then the next digit, I'm going to go all the way over to the 0.07. See, that's how I do this. This is the row, the horizontal. And then this third digit is the column. That's the vertical one. So I want positive 0.047, and whatever's in that slot, that would be my answer because it's less than. So I go 0.04, I go over to the 7, and I'm seeing 0.6808. 0.6808. So that would be 0.6808. Okay, let's do one more. probability z is less than negative 1.09. So I'm going to look for negative 1.0 in the horizontal, and I'm going to look for way over here 0.09 for my next digit. And so whatever's in that slot, negative 1.0 under the 0.09, I see 0.1379. So that would be my value. Okay? So it's a little awkward, but once you get the hang of it, you need to practice it. Unfortunately, we got 2 more issues to go. What if it's more than that? And what if it's between these 2 values? So I need to record this data. So let's get rid of all this. So I'm going to abbreviate this now. The probability that z is less than 0.47 is 0.6808. See, that's a very abbreviated way to say the same thing. The probability that z is less than 0.47. Let's make that 0.47. Okay? So that's with that information. Also, we know that the probability that z is less than negative 1.09 is 0.1379. Now we're going to answer 3 questions. Question 1. What is the probability that the z is more than 0.47? What's the probability that z is more than negative 1.09? And 3, what is the probability that z is between negative 1.09 and 0.47? All right. Now I'm going to draw pictures because if I just say what to do, this is where you will get confused. But I'm going to draw it because I think if you look at the pictures, it makes sense. It's easier to remember if it makes sense. So let's start with the 0.47. I don't need this paper for a minute. What does this mean, this first statement right here? Well, if we imagine a normal distribution, a bell curve, that's not very symmetric. This would be the mean right under the peak. And a z-score is along this. So if this is 1, 2, 3, minus 1, minus 2, minus 3, this is saying if this is 1, standard deviation, 0.47 is about halfway. So out of all the under the curve area, from there back would be 68%. That's what we're saying. If that's clear to you, this should be easy. So what's the probability that z is more than that same 0.47? Right? This was less than. This is more than. This would be the other side. That is what this is asking. How much is that part of it? Do you see that that would be 100% or 1 minus 68%? It's whatever's left. So this is going to be 1 minus 0.6808, which is 0.3192. This is my answer. My answer for this is right there. See, this is what confuses people. They get how to look it up under the table, but they pay no attention to less than or more than. All they know is there's a value on the table. They learn how to do that. Even with the calculator, you have to pay attention to the less than or more than or between, because it has a meaning. It's got an interpretation. The stuff in that table is always to the left. So if you want to know more than, you got to do 1 minus the stuff to the left, and that would be the rest of it, the stuff that's on the right. All right, let's try the second one. So this is 0.392. This is 0.3192. So that's that part. Now let's try to knock this one out. So if I just tell, like, it's going to be 1 minus this, because if this is less than, more than would be 1 minus that. It's the rest of it, right? What's the rest of it that makes up 100%? Let's look at the picture. Here's a normal distribution. Here's the mean. We got to mark it off. 1, 2, 3, minus 1, minus 2, minus 3. Minus 1.09 is just a smidge behind the minus 1. Now this number was less than. 14% of all the data is behind that cutoff, negative 1.09. We want to know how much is more than that. Well, that would be the rest of it. All of it is 100% minus that left part of it, the left tail, would be 13.79%, except we're going to do it in decimal. All of it is 100%. And we're going to take off the green part, and whatever's left would be the red part, that percent. So this would be, what is it, 0.8621. So 86% of all the data would be more than negative 1.09. Okay, well, how do I do what's between it? First, let's visualize it. So here's my normal distribution. Here's the mean. 1, 2, 3, minus 1, minus 2, minus 3. And now I want to be between negative 1.09 and positive 0.47. That is what I'm asking. What percent is all of that? Well, I'm going to draw another picture. I'm going to draw a few so you can see the sequence. Okay. Look at what I want. See the 0.47? That looks like this. See this here? What I'm going to do, if this is minus 1.09 and this is the positive 0.47, what I want to do is take all of this and subtract that and look at what's left. If I take all of this, which is the stuff to the left of or less than 0.47, 0.6808, and if I take away the stuff to the left of minus 1.09, what is left would be the part in question. So let me grab my calculator. 0.6808 minus 0.1379 is 0.5429. So 54% of the stuff would be in between those two z-scores. Now notice, when I do between, those were both numbers I got off the table. I didn't have to worry about the 1 minus stuff. So you take the bigger number, the number off the table, you subtract the smaller number, and that's the stuff in between. All right, so what I'm going to do, I know this video is dragging on, but I'm going to do kind of an overview, real quick bullet point thing, and we'll do one more example. At least watch the bullet points that come up. So if I have the probability that z is less than a number, that is the number off the table in the book. If I want the probability that z is more than a number, then it's 1 minus the number off the table. And lastly, if I want the probability that z is between a number and another number, so between two numbers, it's so it's the larger number from the table minus the smaller number from the table. Less than, you just get it off the table. More than, 1 minus off the table. And if it's between, it's the big number, the table value, minus the little number, the table value. So that's what just happened. Let's do one more example and see these in action again now that you have the list. One, probability z is less than 1.35. 2, probability z is more than 0.63. 3, probability z is between 0.63 and 1.35. Now we're going to run through this. I would press pause right now, do them yourself, and then press play again and we'll check the answers. Alright. Probability z is less than 1.35. I'm going to look for 1.3 and then the 0.5. So when I do that on my paper, 1.305, I get 0.9115. And that's it. That would be 91% or less than that. Okay, next one. I'm going to look for 0.6 and the 0.03. That's what I'm looking for, and that's positive. So 0.6, and then the 3 is 0.7357. But that would be less than. Remember, if you pull the number off the table, that's less than. So our actual answer, the more than, would be 1 minus that. So I'm actually looking at 0.2643. So this is not my answer. It's 1 minus that because of the more than. Okay? Third one, between the two values. How do I do that? Well, I use the number from the table from the larger number, and I subtract, not this number, the number from the table for the smaller number. And whatever that is our answer. So it's 0.1758. All right, so there's the whole thing. I would encourage you to look for other videos if you want further clarification. You need to practice problems, so look at the practice problems in the notes. Play around with this. Our next lesson, I'm going to show you how to do it on a calculator, and then we'll have one more lesson after that. We're going to extend it to non-standards. Okay, do what you can. We'll be back.